Newtonian physics is the foundation of physics. It consists of 3 laws of motion that describes how massive bodies move and interact. Newton published his laws in 1687, and at the time, they were revolutionary. Today, Newton is known around the world, but there was a time in the late 17th century when he was only known in parts of the world, excluding Italy. That is, until the brilliant Italian physicist and academic Laura Maria Caterina Bassi became one of his greatest champions. Il fisico geniale accademico Bassi, the brilliant Italian physicist and academic, was born around October 31st, 1711. Even though Hypatia was one of the first female professors in the world, Bassi was the first woman ever in the history of the world to hold an academic chair and become the highest paid lecturer of her time at the University of Bologna. Bassi was raised in modest surroundings. Her father was a lawyer from Modena. She attended elementary school, and upon completing that, she began to take private lessons. She studied from Father Lorenzo Stegani, who taught her Latin, French, and arithmetic. She also studied from the family doctor, Gaetano Tacconi. For 7 years, she learned and mastered Latin and Greek, as well as the sciences, mathematics, and philosophy. However, her relationship with Tacconi began to decay as she found interest in Newtonian physics, which Tacconi adamantly dismissed. He wanted her to focus on something less controversial, like something from the Cartesian teachings. Regardless, her curiosity for Newtonian theories moved her forward. It inspired her and spurred her into the academic limelight. No doubt she was incredibly learned, a prodigy, and an intellectual's intellectual. Bassi became so famous for her acumen that in March 1732 she joined Bologna's Academy of Sciences. Then, on April 17, 1732, she publicly defended 49 theses at the Palazzo d'Accursio. This was her breakout moment. Bassi was 21 years old, just 21, and ready to take on academics. A month later, in May of 1732, the University of Bologna awarded Bassi her doctoral degree. But it didn't end there. Another month later, she defended 12 more theses, which earned her the unprecedented position of lecturer at the University of Bologna. Yet, much like the societal pressure that Hypatia endured, which led to her declaration of virginity, that's another story for another podcast, Bassi grappled with her reputation as a female scientist. She wanted to maintain her work in science. However, the university was limiting her opportunities to provide reports on her research, as well as give regular lectures. She was kind of forced into teaching from her home because of this. Additionally, the university was pushing her to write poetry and provide commentaries on literature. These 2 areas of academics were not in her wheelhouse. In a letter to Flaminio Scarselli, she writes, "I fear that I would gravely offend the Muses were I to present myself as their servant, who have the honor of seeing them merely in the distance, fleetingly." In other words, she's so far away from literature. Why is she writing commentaries on it? Instead, experimental physics, la nostra fisica, tugged at her heart. It encompassed her mind and filled her with steadfast passion for experimental science. Unlike Hypatia, who taught in Alexandria in 400 CE, and who chose virginity because it gave the impression of pure virginal dedication to her role as a professor, teacher, philosopher, and academic, Bassi chose marriage. Marriage would allow her to visit her colleagues and allow her colleagues to come visit her without any public scrutiny, judgments, or apprehensions. And so Bassi married Giuseppe Verratti, also a scientist, but not nearly as brilliant as her. Many commented that she married somebody who was not her intellectual equal, but he was scientifically curious, which was important to her, and which inspired them to work together in their own research facility in their home. And in keeping with societal expectations, Bassi and Verratti had 12 children. Sadly, only 5 of those children survived infancy into adulthood. Between raising children and maintaining her level of research, as well as her position at the University of Bologna, her opportunities were dwindling. That is until she met Prospero Lambertini, who would eventually go on to become Pope Benedict XIV. The Pope became her greatest champion. The Pope was a big supporter of the sciences. In 1745, he financially supported a research and experimental group called the Benedictina. Bassi hoped to become a member of this elite group of scientists. However, her intellectually inferior husband, instead, was elected to the Benedictina. After 12 years, she had enough. She approached the Pope and asked if she could be added as a 25th member. The Pope unyieldingly agreed to let her become a member, despite the pushback that he endured from existing members. This became her second chance. As a member of the Benedictina Research Group, she now had the platform that she needed to deliver annual reports on her scientific research, which included her work on hydrodynamics, Newton's light refraction, and Boyle's law of gases. Mathematically, she studied the flow of water in canals, which in some way would be the precursor of work with the Navier-Stokes equations. And then there was her work with electricity. This is where she gained her greatest respect. Bassi, in her lifetime, authored 28 papers. Most of these papers covered topics in physics and hydraulics. Voltaire highly respected her. In a letter to her, he wrote, "There is no Bassi in London, and I would be much happier to be added to your Academy of Bologna than that of the English, even though it has produced a Newton." In 1776, she obtained the position of Chair of Experimental Physics at the University of Bologna. Her husband was given the job of her lab assistant. She became the first woman in the history of the world to hold an academic chair. Additionally, over the years, she had been advocating for herself for more pay. And so, as a result, by the time she took the role of chair, she obtained the highest salary for lecturer at the university. Sadly, just 2 years later, she passed away. She left a tremendous legacy that included a life story that served as inspiration for future women in STEM. Today, as we speak, or as I speak on this podcast, there are about 800 million devices using Microsoft Windows. I know that sounds like a non sequitur, but go with me on this. Everywhere we look, we see the Microsoft logo. It surrounds us, and it helps us to identify the product that is in every inch and every corner of the world. The logo uses the tetradic color scheme. Every day, more than likely, you drive by a McDonald's or a Wendy's or a Taco Bell. We identify these places based on the colors that we see. These colors, laid out in a color wheel, help us to understand the theories behind the colors that we see. If it wasn't for Newton's color wheel, we might have evolved to understand color in a different way, or maybe the same way. Regardless, Newton gets the credit. And if it wasn't for Bassi, Newton's theories would not have spread as quickly in Italy. She was his greatest champion. She was his biggest defender. Though we don't have direct evidence of Bassi's work on Newtonian physics and the Newtonian theory of light and colors, we do have her references to Newton's theories in available correspondence. Bassi was passionate about physics. What little time she had raising 5 children, she committed every spare minute to being involved with science and physics. She put the University of Bologna back on the map, and she put female physicists in full view. And she proved to us that our role in life can be more than just being the superheroes that we are in the home. We can also be superheroes in the lab. I'm Gabrielle Birchak, and thanks for listening to Math, Science, History. Nobel season is over. As for women in physics, the 2019 Nobel Prize went to Matilda Jocelyn Gage. I know it really didn't, but please hear me out. Matilda Jocelyn Gage was born in 1826 and died in 1899. She was a 19th century suffragette, an activist and organizer of the Women's National Liberal Union. In 1870, Matilda published a tract called Woman as Inventor. This tract described multiple examples of women in science who had been forgotten or, worse yet, appropriated by their male counterparts. This year's Nobel Prize in Physics and Chemistry didn't really go to Matilda Jocelyn Gage. Instead, this year's Nobel Prize in Physics went to Jim Peebles, Michael Mayer, and Didier Queloz for their work on dark matter and exoplanet discoveries. These are three exceptional scientists in their own right, without a doubt. However, this year's Nobel Prize in Physics highlights the Matilda effect. Science historian Margaret Rossiter coined the term Matilda effect in 1993 in her publication, The Matthew-Matilda Effect in Science. In her work, she explained the ongoing systemic occurrence wherein the work that female scientists do goes unrecognized while the credit goes to men. Women have been severely underrepresented in science, and though there are more and more women receiving their PhDs in science-related fields, the overall percentage of women in science has not increased significantly, simply because more men are also entering these fields as well. This is perfectly fine, as everybody in STEM matters. However, this ongoing problem of women being overlooked and their male counterparts being awarded is common. Dr. James Peebles, the gentleman who won this year's Nobel, earned it from studying the earliest moments of our universe right after it was born. From his study, he created a theoretical framework that helped us to understand the evolution of the cosmos, all of which leads us to understand dark matter and dark energy. In 1965, astronomer Vera Rubin discovered a halo of something dark that surrounded each galaxy. That matter, which was a mass, spread throughout each galaxy. She had found that the gravitational force and the orbital speed of these galaxies were similar throughout. That mass is dark matter. This was in 1965. In 1965, Vera Rubin discovered dark matter. I will say this again. In 1965, Vera Rubin discovered dark matter. Sadly, Dr. Rubin passed away 3 years ago. She never won a Nobel Prize for this discovery, which, by the way, was fundamental to astrophysics. In 1903, Marie Curie won her first Nobel Prize. However, she would not have received it if it weren't for her husband, Pierre, who advised the committee that Marie had a pivotal role in her discoveries in radioactivity. Dr. Lise Meitner, who collaborated with Otto Hahn, discovered nuclear fission. And even though Niels Bohr nominated Dr. Meitner first and Dr. Hahn second, the lone winner of the Nobel Prize in 1944 went to Otto Hahn, and he never included Dr. Lise Meitner as a co-author. Dr. Marietta Blau, an Australian physicist, did pioneering work with the pion. She, along with female physicist Hertha Wambacher, were even nominated for the Nobel by Erwin Schrödinger. However, they were passed up, and Cecil Powell received the Nobel Prize in 1950 for his development of the work that utilized Dr. Blau's discoveries. Then there was Dr. Cecilia Payne, whose dissertation proposed that stars were composed of hydrogen and helium. It was her advisor, Henry Norris Russell, who was nominated for the 1953 Nobel Prize. Russell did not win his prize. Instead, it went to Frederick Zernike for his invention of the phase contrast microscope. In the 1950s, Dr. Chien-Shiung Wu, the First Lady of Physics was conducting work on the radioactive decay of the unstable isotope cobalt-60. Long story short, in 1956, she found a large asymmetry in her experiments on cobalt atoms. However, physicists Tsung-Dao Lee and Chang-Ning Yang, who were conducting further experiments through the guidance of Dr. Wu, won the Nobel Prize in 1957. Then there is Esther Lederberg, a renowned microbiologist who, along with her husband, created a new method of replica plating, which was a new convenient way to transfer bacterial colonies from one petri dish to another. This opened the door to future studies in antibiotic resistance. This method of replica plating was essential for her husband to receive the 1958 Nobel Prize for Physiology or Medicine. We must not forget Rosalind Franklin, a British biophysicist and DNA pioneer. While at King's College in London, she had to leave the building every day at lunch because women were not allowed in the cafeteria. Unhappy at King's College, she eventually left. However, senior scientist Maurice Wilkins, during her move out, got a hold of her notes and took key images from them. He shared that information with his friends, who among them was Francis Crick. Crick went on to win his Nobel Prize in 1962. Jocelyn Bell Burnell discovered the pulsar. However, in 1974, the Nobel went to Anthony Hewish and Martin Ryle for their work with pulsars. Dr. Bell was a student of Dr. Hewish at the time of her discovery. The list goes on. Trota of Salerno, the 12th century Italian physician who wrote books on her work, continues to be unnamed because all of her work was attributed to male authors. Pandrosian, the female math teacher in 4th century Alexandria, was written into our history as a man. Dr. Alice Augusta Ball, the brilliant African-American chemist from Seattle, found a revolutionary treatment for leprosy. Arthur Dean, who co-taught chemistry with her, continued her work and got all the credit. Dr. Nettie Stevens, the genius geneticist who, while working with mealworms, discovered that male mealworms produced sperm with X and Y chromosomes, and females produced cells with only X chromosomes. However, all the recognition went to Thomas Hunt Morgan. Dr. Mary Whitten Calkins, psychologist and philosopher who made groundbreaking discoveries for her work on stimuli, is attributed to George Elias Muller and Edward Titchener. Dr. Martha Gautier was a medical doctor and researcher who discovered the chromosomal abnormality that causes Down syndrome. All of her work is attributed to Jerome Lejeune. And then there was Dr. Marion Diamond, who discovered the phenomenon of brain plasticity. In 1964, she was about to publish her paper on this work when she discovered that two other authors, David Kretsch and Mark Rosenzweig, had their names placed before hers. Dr. Diamond protested, and her name was given first place. She rocks. Then there are the female unnamed heroes who were part of the programming ENIAC, the Electronic Numerical Integrator and Computer. These amazing women include Adele Goldstein, Kay McNulty, Betty Jennings, Betty Snyder, Marilyn Westkoff, Fran Bilas, and Ruth Lichterman. The list goes on and on and on. Women's efforts in science are not less important than men's efforts in science. They are equally important. Our greatest developments in science can only come when diversity is welcome and embraced. So, how do we fix the Matilda effect? There are so many ways. The answers to fix this are right in front of us, and it's been said over and over and over again, but I'll say it too, because I have a podcast. So here are the things I think we need to do. 1, recognize our unconscious bias. We all have it. It's there. We need to recognize it. 2, create committees that are more diverse. And I'm not just talking about gender diversity. I'm talking about race diversity as well. 3, create a transparent process that defines the selection process. This transparency is essential. It allows for the input of those on the outside to recognize the unconscious bias. 4, rewrite the material. Rewrite it all. Change the language. Make the words less gender specific. Words have power. All of our words have so much power. So when we write these awards, let's rewrite them so that when we propose the awards, there's no confusion as to who can apply. If everybody can apply, then that needs to be specifically clear. This is also necessary for the evaluation process too. 5. Create nomination pools in such a way that there are equal amount of women as there are men in the nomination pools. And if we find that men are still winning more of these awards, let's go back to point number 1. Let's evaluate our unconscious bias. Number 6, men. Step up and be more like Erwin Schrödinger and Niels Bohr. Nominate women, please. We need this. There are many, many, many brilliant women in the world who deserve to be recognized for their efforts. 7. Finally, please don't be complicit. Call out bias when you see it. Calling it out helps to normalize the reality that women are highly qualified scientists too. 8. Scientific journals, please help us to change the bias by looking at how many papers are submitted by women versus how many papers are published by women. And 9, women, publish your work and keep trying to publish your work. Please be active about this. Your work matters. It matters to science. It matters to other women in science. It matters to our diversity. It matters to our daughters. And most importantly, it matters because we want to celebrate your work. If you are listening to this podcast on Monday, December 9th, join me in celebrating Rear Admiral Grace Hopper's birthday. Grace Murray Hopper was born on December 9th in 1906 in New York, New York. If you have never heard of Admiral Hopper, you should know that she defined tenacity. As a young girl, she was very curious and brilliant. She applied for college at the age of 16 at Vassar College. However, she didn't get in because her Latin test scores were too low. So, a year later, she applied again and she got in. In 1928, with a bachelor's in mathematics and physics in hand, she graduated from Vassar with Phi Beta Kappa honors, which means she graduated with at least a 3.8 GPA. 2 years later, she earned her master's degree at Yale. 4 years later, she had earned her PhD also from Yale and began teaching at Vassar in 1931. Hopper wanted to join the Navy when World War II began. However, the Navy believed that she was too old to enlist because she was 34 years old, and they believed that her work as a mathematics professor was too valuable an asset for the war efforts. Also, she was a skinny mini, and so they thought that her height and weight was too low. However, 3 years later, shortly before her birthday, she had this deep realization that she needed to change her life. So, she reapplied to the Navy. She ended her 15-year marriage, received a leave of absence from the university, and was sworn into the United States Navy Reserve. She graduated first in her class, of course, at the Naval Reserve Midshipman School at Smith College. Her first assignment was as a junior grade lieutenant to the Bureau of Ships Computation Project at Harvard University. She loved it there so much that when the war was over, Vassar tried to hire her back with the position of full professor. However, she decided to stay with the Naval Reserve, working at the Harvard Computation Lab. In 1949, she started working with Eckert-Mauchly Corp., working as a mathematician and developer for the UNIVAC. In her first few years there, she had this idea to make a computer that could program itself using English words. See, back then, machine codes were used to give computers instructions, but her idea was to create a computer that could take in the words and then translate them back into machine code. This is also known as a compiler. However, even though she introduced it, her idea was dismissed. But this is Grace Hopper. She defined tenacity. She wrote a paper about it that was published in 1952. This was also the same year that Remington Rand took over Eckert-Mauchly and moved forward with her idea to create a compiler. By 1954, Hopper became Remington Rand's first director of automatic programming. By this point, she had turned her compiler into the Flowmatic compiler, which then became the foundation for COBOL, C-O-B-O-L, COBOL. It's an acronym for Common Business-Oriented Language, and that's basically what it is. It's a coding language for business data processing, and this includes accounting systems, database systems, payroll systems, inventory systems, and pretty much anything that a company would need to help run a business. Her contributions to this language were so valuable that she earned the nickname Grandma COBOL. Fun fact, she was the very first person to coin the term debugging when a moth got caught in one of the electrical switches controlling the circuits on a Mark II computer that had broken down at Harvard in 1947. This moth was caught in the system and they removed the moth, and so began the term debugging a computer. This infamous moth is now on display at the Smithsonian. Grace Hopper served our military on and off from 1944 to 1986 when she retired. She had worked her way up in the Navy from midshipman all the way up to rear admiral. In 1996, the USS Hopper, a Navy warship, was named after her, and it was nicknamed Amazing Grace. In 2001, the Government Technology Leadership Awards were named in her honor and are called the Gracies. In addition to earning her PhD, she was awarded 40 honorary degrees from universities around the world. Among her multitude of awards, she has received 9 military awards, and in 2016, she was posthumously awarded the Presidential Medal of Freedom for her accomplishments in computer science. I've placed a video of her in an interview with Walter Cronkite on 60 Minutes on my website, mathsciencehistory.com. It's a great interview, and what I love most about this interview is the way her face lights up when she talks about her work with the Navy. Admiral Hopper sadly passed away on January 1st, 1992, but she left a tremendous legacy. Comic book series have been written about her, the first robotics competition world championship is named for her, and the annual conference Grace Hopper Celebration of Women in Computing is held every year. Admiral Hopper's greatest legacy was all the training that she did for the Navy. She was most proud of her commitment to the Navy for 43 years, training young service members for the Navy and giving back to our country. For me, what I admire most about her was her curiosity. When she was teaching at Vassar, she made a point to audit 2 classes a semester that had absolutely nothing to do with what she knew. So here we have this brilliant woman with a PhD in math and physics, and she didn't just focus on one thing. She broadened her knowledge in all areas. She spent her life finding new ways to approach a challenge. One of my favorite quotes of hers is, "Humans are allergic to change. They love to say, we've always done it this way. I try to fight that. That's why I have a clock on my wall that runs counterclockwise." Well, the holidays are over, and with a lot of catching up to do, I've decided to do a podcast about a research project that I've undertaken for the last 3, almost 4 years now. I'm going to talk about the mathematics professor, philosopher, and astronomer Hypatia of Alexandria. Hypatia lived in Alexandria, Egypt in the 4th and 5th centuries as a mathematician and philosopher. However, she is most famous for the way in which she died. On March 8th, 415, Hypatia was murdered. She was leaving her place of lecture, which might have been the archaeological area that is now known as Combe el Dika. She was on her chariot when a mob of angry church members, under the influence of Alexandria's Pope Cyril, ripped her away from her carriage. They then stripped her of her clothing and then skinned her while she was alive. They ripped her apart limb to limb. Then the angry mob carried her limbs to the Cineron, which was located near the Caesareum, where they burned every last trace of her. It was a horribly tragic death that not only brings a level of shock to the current reader, but it also shocked Alexandria at that time. You see, Hypatia was loved by Alexandria. There are many myths about her reputation, but the truth is she was honored and appreciated by the diverse citizens of Alexandria, the government, and the church. Many people believe that Hypatia's murder was actually the end of scientific development in Alexandria. The stories that circulate on the internet say that this was when the great library was burnt to the ground. However, that's not the case. The library had been in decay for hundreds of years before Hypatia was even born in Alexandria, and this decay is actually noted by the ancient renowned historian by the name of Strabo. But back to Hypatia, she was quite an accomplished mathematician. Her father, Theon, was also a mathematician, and he trained her to follow in his footsteps. She was so good at what she did that academics and historians who lived near that time wrote about her intellect and how she actually surpassed her father in aptitude. It's noted in historical works, and it's actually been extensively researched, that she worked on many commentaries. Now, back then, commentaries were considered to be like workbooks and supplements to the original scientific publications. So, she worked on commentaries that included Archimedes' dimension of a circle, Euclid's Elements, Diophantus's Arithmetica, Apollonius's Conics, as well as isoperimetric surfaces and curved surfaces. Possibly, she worked on many more. It's unfortunate that almost all of her work does tangibly not exist in our current time. However, many incredible historians, including Wilbur Knorr and Adolphe Rome, have conducted extensive research showing how some of her work had been copied and built upon by scholars that came after her. So her work did live on. Hypatia was a pagan philosopher who taught Neoplatonism. She was also an astronomer who worked with astrolabes and wrote excerpts for the Almagest, which was a grand mathematical tome that assists in charting the stars. So her murder actually ties to these key pieces. There are stories that Hypatia was a witch who used astrolabes and beguiled the governor of Alexandria. This is not true. The whole story about her being a witch actually comes from propaganda that was perpetuated by the church hundreds of years after her death. And ironically, this propaganda coincided with the canonizing of Cyril of Alexandria. The story is this. Hypatia was a beloved philosopher who taught Neoplatonism. At this time, there were two prominent philosophies in Alexandria. One was Neoplatonism, which, for the sake of time, focused on developing a single relationship with a single spiritual entity. The other prominent philosophy being taught in Alexandria at that time was Iamblicanism. It was a philosophy that actually utilized the sacrifices of animals. It would be like the difference between Judaism and metaphysics. Her role as a philosopher and government advisor was honored by Alexandria. She was so loved by academic circles and the people of Alexandria that when government leaders and elites would visit the city, they would actually visit her first out of honor. In her classroom and in evening meetings with her disciples, she exemplified the importance of tolerance. The church didn't hate her, nor did she dislike the church. As a matter of fact, she was a public professor and had a diverse student body that traveled from far distances to come and learn from her. Some of her students were devoted pagans, others were dedicated Christians, and others were honorable Jews. So her lessons had created the perfect platform to incorporate a relationship with God into philosophy, and it worked absolutely perfect for her. So at this point, she had no qualms with the church. As a matter of fact, when she was a burgeoning professor just starting to take over her father's school, she had garnered an alliance with the then Pope of Alexandria, Theophilus. Theophilus valued her contribution to Alexandria so much that he even resided over the marriage of one of her disciples, Synesius. However, Theophilus grew old and passed away. Then, his nephew forced his way into the position. This was Cyril. Cyril didn't ascend to the throne. As a matter of fact, his uncle had taken away some of his church privileges months before he passed away. But Cyril manipulated his way into the position of the Pope of Alexandria. There was pushback by a group of Christians who wanted another person, Bishop Timothy, as their pope. This group saw Cyril as an iron-fisted leader. Cyril was not a good guy, and he was the one person who hated her so much that even historians of this time recognized it. The Suda notes his jealousy, and other historians, such as Damascius, wrote about his jealousy of Hypatia in his work called The Life of Isidore. It was shortly after Cyril became pope that Hypatia became an advisor to Orestes, who was the new governor of Alexandria. Also around this time, there had been a lot of infighting between the different enclaves of Alexandria. And even though there had been fighting between the Jews and the Christians and the Christians and the pagans, the government and the church were able to keep peace in the city. However, there was one particular day when everything started to go south. To make a long story short, Orestes and Cyril had been at odds with each other. There had been complaints about the loud Jewish Sabbath celebrations that were held on Saturdays. It was Orestes' job to maintain peace in the city. However, he didn't want to prohibit the celebrations. He wanted them to continue to maintain peace. This might have been advice from Hypatia in order to maintain tolerance in Alexandria. So, on the day that he announced this allowance in the theater, Cyril's subordinate, Hierax, was in the theater heckling Orestes. Orestes had Hierax arrested and tortured, which infuriated Cyril, who ordered that the Jews be punished. The Jewish community of Alexandria refused to be manipulated by Cyril, and so they arranged to have a street battle with the Christians. So, a day after this, Cyril encouraged his parishioners to enter the Jewish synagogues, apprehend the Jews, and expel them from Alexandria. This move actually depleted a large portion of Alexandria. Cyril then tried to manipulate Orestes into reconciling with him, which would actually tip the scales of power to the church. Orestes didn't want this. It wouldn't bode well for the diverse community of Alexandria, and Orestes knew it. The infuriated Cyril decided to command his Nitrian monks who lived outside of the city to come in and attack Orestes, which they did. This infighting continued between Cyril and Orestes, and Cyril really felt threatened by Hypatia's advisory role to Orestes. And so, from the pulpit, Cyril encouraged the Nitrian monks and his parishioners to harass her. But the harassment went too far, and they murdered her. Many people believe that this was the end of Neoplatonism. However, it wasn't. It was only the end of Hypatia's Neoplatonism. It was the end of a tolerant community empowered by a like-minded philosophy that encouraged tolerance and peace in Alexandria. And so after her murder, philosophy evolved into something that was a bit more suspicious and divisive. Philosophers began to immigrate out of Alexandria and go to Constantinople and Athens. Many philosophers tried to follow in Hypatia's footsteps. However, many were unsuccessful. She had established a school of education and philosophy that could never be duplicated in Alexandria again. Hypatia left a tremendous impression on Alexandria and in the world, because we're talking about her today. She was also horribly missed among the leaders in the government and in the church, so much so that within a year after her murder, the Roman Emperor Theodosius II established an edict to place restrictions on Cyril's activity and prohibit him from ordering his parishioners to carry out his deeds. What made this edict incriminating was that Cyril was named in this mandate. Hypatia literally gave her life to be a professor. To me, the story reflects the people who become academics and professors and who commit their entire lives to learning and then teaching in order to make this world a smarter place. The only way we can create an intelligent planet is to diligently learn, inclusively share, and optimistically hope that we can perpetuate our own personal inspirations. Inspiration is the most powerful legacy, and I know this firsthand from my own professors and advisors who I am so grateful for. So, to set the false stories straight, Hypatia was not a witch, nor did she beguile men to do her biddings. She was an amazing professor, a philosopher and a mathematician. She was loved by the city, by the government, and by the church. The story of her life is really an amazing one. Her contributions to mathematics and astronomy were extensive, and the philosophies that she taught her disciples lived on. Hypatia was a gallant martyr. She was a defender for academia, she was a role model for mathematics, and she was a Neoplatonic saint. But mostly, for all that she did in her lifetime, Hypatia was a champion for tolerance. Join me in celebrating Black History Month. So many incredible stories about perseverance, dedication, hard work, humanism, empathy, and brilliance are shared throughout the entire month celebrating Black culture. For the month of February, I've decided to do a series of podcasts honoring the brilliant, Black, badass goddesses who continue to forge paths for the marginalized in STEM. Every week, I will be doing a podcast on a super shero in STEM who deserves to be recognized for her rise in STEM. This week, I would like to introduce you to Dr. Roger Arliner Young. Dr. Young was born in Clifton Forge, Virginia in 1889. Shortly after, her and her family moved to Burgettstown, Pennsylvania. Her family wasn't affluent. They weren't even middle class. They were poor. However, this did not stop Young from pursuing her dreams, which were originally in music. I love this tidbit about her, where she wrote in her yearbook that not failure, but low aim is a crime, and she aimed high. Academically, she struggled. She had been studying music at Howard University for 5 years. Then, in 1921, she took her first science class. At this point, Young had hit her stride. She knew what she wanted to study, and she knew what she wanted to be, and she never wavered in her determination. She fell in love with zoology. She was enthralled with the scientific study of animal life, the structures, the physiology, the resilience, the evolution, the behavior, and the survival of animals from their cellular level to their powerful, profound existence in the world. After that class, for the next 2 years, she studied from Dr. Ernest Everett Just, who was an influential Black biologist and the head of the zoology department at Howard. Just saw intelligence and aptitude in Young. Even her classmates characterized her as lively and vivacious. She was involved in different college organizations, including Glee Club, Young Women's Christian Association, and Howard University Players, which is a student-run performing arts group. So, she was not only talented, she discovered that she was smart. 2 years after choosing zoology as her field of study, she graduated with her bachelor's degree. Then she wrote her first and only sole published paper titled On the Excretory Apparatus in Paramecium. It was published in the September 12, 1924 edition of Science magazine. This was a magazine that even accomplished scientists have minimal success of being published in. It was a tremendous success for Young. She was the first Black woman to research and publish in the field of zoology. Young was eager to go on to graduate school for her master's, and so Just tried to help her find funding, but to no avail. Nevertheless, Young was unstoppable. She knew what she wanted, and she pursued it. So, in 1924, she enrolled at the University of Chicago on a part-time basis. 2 years later, she graduated with her master's in zoology. While at the University of Chicago, her grades improved even more so much that she was elected to the Sigma Xi Honorary Society, which was quite an accomplishment because in order to be invited to the Sigma Xi Honorary Society, one had to already be a doctoral candidate, and she wasn't. She was still working on her master's. After she received her master's, Just hired Young to assist him as a professor of zoology in his department at Howard University. So, back at Howard University, she worked with Just, helping him to manage the workload with his classes and assisting him in the lab. She also worked with him as his research assistant at the Marine Biological Laboratory at Woods Hole, Massachusetts for 2 years between 1927 and 1929. While at Woods Hole, she found a second home. For the next 9 years, she would visit Woods Hole and work in the laboratory every summer. This opportunity at Woods Hole was quite an accomplishment. She was the first Black woman to join the scientific community in Woods Hole. However, there was still a lot of interracial bias at this time. In addition, Young had realized that some of her challenges weren't just because she was Black, but that she was also a woman. Nevertheless, she continued in her research and gained the respect of many of her peers and their mentors. From 1927 to 1928, Just had been developing new research that included the effect of ultraviolet light on the development of marine eggs. So, after her master's degree, she was back at Howard working for Just, but her workload was tremendous, especially after Just traveled to Europe on a research grant. She carried his workload and seized every spare minute that she had to write proposals for funding so that she could continue in her doctoral studies. Despite the workload, she kept moving forward. In the summer of 1929, Young went to Woods Hole, where she worked alongside embryologist Frank Lilly from the University of Chicago. This was an advantageous summer for her. The General Educational Board rewarded her with the fellowship so that she could continue with her doctoral studies. Shortly after Just returned from England, Young left for the University of Chicago to study from Lilly and prepare for her qualifying exams in order to enter her doctoral studies. In January 1930, just 1 week before Young was to take her qualifying exams, Just left for Europe again. She was overwhelmed taking on Just's duties and preparing for her exams, and she was struggling physically. The work with ultraviolet light that she had been doing for Just had permanently damaged her eyes. She was also struggling financially because she solely carried the financial burden of taking care of her mother, who was very sick. She didn't have enough money for research, travel, or her family. She, like so many other graduate students, suffered the emotional and physical demands of America's academia that seldom provides a healthy work-life balance. And so she failed the qualifying exams. The University of Chicago denied her acceptance. Then things got worse. Because she was denied acceptance to the University of Chicago, her place at Howard became precarious. Just and the president of Howard University, Mordecai Johnson, had plans in place for the zoology department. The department had been awarded a grant of $80,000. That's a lot of money for 1930. They had assumed that Young would complete her PhD and then return to help the department flourish. However, after being denied by Chicago, Young was emotionally shattered. She wrote to Dr. Lilly upon her departure, saying, quote, "The trouble is that for 2 years, I've tried to keep going under responsibilities that were not wholly mine, but were not shared, and the weight of it has simply worn me out," unquote. In short, Young was exhausted. Nevertheless, back at Howard, she kept moving forward. That summer of 1930, she went to Woods Hole to work in the lab alongside Dr. V.L. Heilbrunn of the University of Pennsylvania and his student Donald P. Costello. All three worked together conducting marine egg studies. From 1931 to 1935, Young's position at Howard became difficult and questionable to the university. Despite the fact that Just had convinced Young to stay at Howard, even though she was offered a position at Spelman College in 1931, their working relationship fell apart. Just had been ignoring her and treating her coldly. Meanwhile, Johnson, Howard's president, informed Just that he needed to make budget cuts and to let one of his 3 junior professors go. So, when Young confronted Just about his attitude towards her, he impulsively fired her. Winnie Warren, she is the author of the book Black Women Scientists in the United States. It's a wonderful book. She explains it perfectly, where she writes, quote, Perhaps one of the most crucial elements in Young's fate at Howard University was that the school's power elite was not particularly supportive of women during this period, unquote. So Young had so much going for her, but like many Black women, even today, her career suffered because of marginalization and gender bias. Again, that didn't stop her. She kept going. She continued to work with Heilbronn and Costello, and together, the three of them wrote 3 papers for Biological Bulletin that were published in 1935, 1938, and 1939. In 1937, she was accepted into the doctoral program at the University of Pennsylvania and received a 2-year grant from the General Education Board to study there. She finally earned her doctorate. Shortly after that, she obtained a position at North Carolina College for Negroes in Raleigh, North Carolina. And then, after that, she was hired on as the head of the biology department at Shaw University. In 1947, she went back to North Carolina College as a biology professor. Unfortunately, though, she could never get ahead of her financial difficulties. She could no longer afford to go to Woods Hole to conduct any more research. Also, North Carolina and Shaw could not afford the research equipment necessary for her to carry out research at the school. In 1953, her mother passed away. This shattered her. Emotionally, she couldn't rationalize. She began to have a psychological breakdown and a financial breakdown as co-workers whispered about her mental state. Broken and distressed, she tucked herself into the Mississippi Mental Asylum in Whitfield. Even though she was discharged in 1962 and held a position as a temporary visiting lecturer at the Southern University in Louisiana, she continued to struggle with emotional stability. Winnie Warren writes that perhaps her 10-year working relationship with Just did not enable her to outgrow her dependence on her mentor. Perhaps she had become so reliant on her mentor that she had been conditioned to not think for herself. Based on her confidence and determination in her undergraduate years, if she had been weaned off of the enabling of her mentor, she might have overcome the challenges that academia and life presented her with. And because of that, and again, I have to say, the lack of work-life balance in academia, because of that, Young couldn't quite overcome her personal difficulties. She might have taken that position at Spelman College in 1931. She might have lived a different life. She might have found her niche and success in academia. On November 9, 1964, Dr. Roger Arliner Young passed away in New Orleans, Louisiana. She was the first Black American woman to get her doctorate in zoology. She didn't just forge a path for Black women in zoology, she blazed it. She was a scientist in an age long before civil rights. She overcame numerous obstacles to pursue her dreams. Every day, as she found joy in discovery, she had to push against the world of academia that held onto the antiquated belief that women didn't belong in the field of science. And when some of her pursuits failed, she simply tried again. She had tenacity, determination, and grit. She never gave up on her dream to get her doctorate and do her research. When her personal situations became enormously difficult, the science that she loved so much gave her hope. It's February 2020, and it's Black History Month. For the month of February, I've decided to do a series of podcasts honoring the brilliant, Black, badass goddesses who continue to forge paths for the marginalized in STEM. Every week, I will be doing a podcast on a super shero in STEM who deserves to be recognized for her rise in STEM. Today, I'm going to be talking about Shirley Ann Jackson. Time magazine once wrote that Shirley Ann Jackson is perhaps the ultimate role model for women in science. She is also the first Black woman in America to earn a doctorate in physics. She is the first Black woman to receive a doctorate from MIT. She is the president of Rensselaer Polytechnic Institute. She has served on boards of directors for banks, electric power companies, oil and gas companies, and the MIT Corporation. Her list of accomplishments and devotion to science and government has earned her 45 honorary doctoral degrees. She is an extraordinary woman with astonishing accomplishments who has achieved so much in her life with absolute tenacity and determination. Jackson was born in 1946 in Washington, D.C. Unfortunately, at this time, systemic racial bias permeated our communities and our laws, which means that segregation was legal. As a result, growing up, she was barred from attending an all-white school near her home, and so she had to travel across town to attend a black school with her sister. She was 8 years old when the Supreme Court ruled that segregation in educational institutions is against the law. Even so, systemic bias still permeated communities across the country. Jackson's parents encouraged her to do well in school. Her mother was a social worker and her father was a postal worker. Together, they encouraged Jackson to develop her reading and writing skills, and they inspired in her a love for math and science. Growing up, she was curious, precocious, inquisitive, and motivated. Jackson, fascinated with nature and science, raised bumblebees in the basement of her home as she studied them and took exceptionally detailed notes about the bees. She excelled at school and flourished at home with her sisters, doing fun things like building soapbox carts. By the time she attended Roosevelt High School, she was a straight A student taking accelerated classes in math and science. At her graduation in 1964, she was the high school class valedictorian. She seized this opportunity to set her sights on a college that could allow her to pursue what she was most passionate about: science. She applied to go to Massachusetts Institute of Technology at the encouragement of the assistant principal for boys at Roosevelt High, and she was accepted. When she entered MIT, even though it seemed as though she was welcome there, racial bias still existed. It was a lonely existence in the entire school because she was only one of 45 women and only one of about 13 African Americans in the entire freshman class that consisted of about 900 students. In her physics classes, nobody wanted to work with her, including the women. Jackson says, quote, "The irony is that the white girls weren't particularly working with me either. I had to work alone. I went through a down period. But at some level, you have to decide you will persist in what you are doing, and that means you won't let people beat you down," unquote. The racial bias and personal discrimination at MIT at this time was so bad that the other girls didn't even want to sit in the same cafeteria with her. Regardless, she never gave up. With the help of scholarships from Prince Hall Grand Masons and the Martin Marietta Aircraft Corporation, she studied condensed matter theory and earned her bachelor's in 1968. Next up, grad school. As the brilliant woman that she is, she was accepted into Harvard, Brown, and the University of Chicago. But she chose MIT with support from more grants and began her graduate-level courses in theoretical high-energy particle physics. While at MIT, both during undergrad and grad school, she served as co-chair of the Black Student Union and then advisor as a graduate student. But she didn't stop there. She kept going. She set up recruiting committees, and I love this next part. She got a commitment from MIT to adjust the requirements needed for admission so that incoming minority students would also have an opportunity to attend MIT. Jackson didn't just flourish at MIT. She didn't just set an example for other women and for other blacks. She helped pave the way for them. As she rose in her successes, she made a point to pull others up with her too. Jackson earned her PhD in 1973. She was the first Black woman in the United States to earn a doctorate in physics. Within her first several postdoctoral years, she worked as a research associate for Fermi National Accelerator Laboratory, CERN, which is the European Organization for Nuclear Research, Stanford Linear Accelerator Center, and the Aspen Center for Physics. Then, in 1976, she joined the theoretical physics staff at AT&T Bell Laboratories. During this time, she fell in love with a fellow physicist, Morris Washington, and married him in 1979. In 1981, her son, Alan, was born, and during this time in her life, she served on an advisory panel to the United States Secretary of Energy, other councils for the National Academy of Sciences, and on the advisory council of the Institute of Nuclear Power Operations. But that's not all. She was also an advocate for Black women in science. She was an advocate for education, and so she also served on committees with the National Academy of Sciences, the American Association for the Advancement of Science, and the National Science Foundation. In 1982, she received the Candace Award for Technology from the National Coalition of 100 Black Women. In 1990, she received the Thomas Alva Edison Science Award. In 1991, she was elected as a Fellow of the American Academy of Arts and Sciences. In 1995, President Clinton appointed her as a chairman of the United States Nuclear Regulatory Commission. She was the first Black woman to serve on the NRC, and she was the first Black woman to lead the NRC. In 1998, she was honored by the National Women's Hall of Fame. In 1999, she became the 18th president of Rensselaer Polytechnic Institute. She still serves in that capacity today, 21 years later. In 2001, she received the Richmeyer Memorial Lecture Award with the American Association of Physics Teachers, and she became the first African-American woman elected to the National Academy of Engineering. In 2007, she received the esteemed Vannevar Bush Award for, quote, a lifetime of achievements in scientific research, education, and senior statesman-like contributions to public policy, unquote. In 2012, she was appointed an International Fellow of the Royal Academy of Engineering, and in 2014, she was awarded the National Medal of Science. Outstanding doesn't even begin to describe Shirley Ann Jackson. Jackson once said that what drives her is the ability to make a difference, and no doubt, she has made a difference. The list of her awards and honors is lengthy and so well-deserved. However, what supersedes her awards is her remarkable lifetime dedication to science, to education, to our government, and to empowering others. If there is one thing that most professors want, they would say, a legacy. Angie Turner King was one of those professors who accomplished just that. If you don't recognize her name, maybe you would recognize the students that she inspired and encouraged. Among all of the amazing students that she inspired, the few that stand out are Catherine Coleman Goebel Johnson, the infamous mathematician who helped John Glenn orbit the Earth; Margaret Strickland Collins, a child prodigy and a famous entomologist who specialized in the study of termites; and Jasper Brown Jeffries, who worked on the Manhattan Project in Chicago. In a questionnaire provided in the West Virginia State High School Reunions book, 38% of respondents chose Dr. King as their favorite professor. Of those respondents who chose Dr. King as their favorite teacher, 50% of them went on to graduate school. These students were her legacy. These were the students that she inspired and encouraged to pursue mathematics and science. Dr. King was born in 1905 in McDowell County, West Virginia. She was the eldest daughter of William and Laura Turner. She had two other siblings, Sylvia and Irving. She was the grandchild of Virginia slaves, and her early life was not easy. When she was 8 years old, her mother passed away, and so she went to go live with her grandmother. Dr. King describes her grandmother as a woman so light-skinned that she was almost white. Living conditions with her grandmother were not ideal. She slept in the upper level of a cabin, and in the winter, when it would snow, she would wake up with snow in her bed. However, King said it didn't bother her. While she was in high school, she lived with her father, and her father encouraged and insisted that she go to school even when she didn't want to attend. His insistence worked. She graduated from high school at the age of 14 in the year 1919. Dr. King says that when she graduated, her teachers encouraged her to go to college. However, neither she nor her teachers knew anything about scholarships or grants. And so, unaware of funding opportunities, she attended Bluefield Color Institute for teacher training. Even then, the encouragement of her previous teachers inspired her to transfer to West Virginia State College. She was still unable to find scholarships and funding. She says, quote, "I worked for my education. There were no scholarships in those days. Mostly I waited tables, I washed dishes, anything like that I could get to pay for school," unquote. Finally, 8 years after she graduated high school, she earned her undergraduate degree in mathematics and chemistry. She graduated cum laude. This was only the beginning. She began teaching at State High School and at the Laboratory High School in West Virginia State College. West Virginia State College was one of the few colleges in the area that opened up laboratory schools that enrolled secondary and elementary school students. This allowed them to receive a higher education than what the public schools could provide. So, during the summers, King attended Cornell University. Once again, she paid for the tuition herself without relying on scholarships or grants. In 1931, her thesis was on interactions between solutions of tannic acid and hydrospheric oxide, and she earned her master's degree in mathematics and chemistry in 1931. After 8 years of teaching at the Laboratory High School at West Virginia State College, they offered her a position at the college. Her first order of business was to create a chemistry lab for the students so that, quote, "students would know what a real laboratory was like," unquote. King kept busy. During World War II, she taught chemistry to soldiers in the Army Specialized Training Program at West Virginia State College. She had unlimited energy. She married in 1946, had 5 daughters, and then attended the University of Pittsburgh, where she earned her PhD in mathematics and chemistry. Again, without any financial aid, she paid for the tuition herself. In 1954, King received the West Virginia State College Alumnus of the Year Award. She graduated in 1955 with her PhD in mathematics and chemistry. Her dissertation was on an analysis of algebra in school textbooks before the year 1900. Back at West Virginia State College, King committed 41 years of her entire career to teaching at West Virginia State College. She loved teaching, and she was very involved with many of the Women's Day events at West Virginia State College. She was honored by the West Virginia Women's Commission as an outstanding West Virginia woman in the field of science. King retired in 1980, and she remained in the on-campus housing until February 28, 2004, when she passed away. She lived to the age of 99. That is a life well lived. Dr. King's students went on to become doctors, leaders, and contributors to the world of science and mathematics. Though she didn't write any papers other than her dissertation and her thesis, she instilled in her students a passion for mathematics. By words and actions, she encouraged her students to pursue a higher education. And she lived an exemplary life of a brilliant woman who, to this day, continues to inspire women to follow in her path. Through her dedication to encouraging others to pursue STEM-based academics, she forged not just a path, but a highway and multiple paths through her legacy, through the students that she taught. She wasn't a published professor. However, she did something so much more. She opened up so many doors for so many African Americans so that they could continue with her legacy and encouraging even more Blacks and African Americans in STEM-based industries. Thanks to Dr. Angie Turner King, STEM-based academia has become filled with the diversity that this country desperately needs. Though there is still so much more work to be done, Black academia is so much better because of Dr. Angie Turner King. Clearly, Dr. King understood the power of legacy. If you are listening to this podcast on March 23rd, join me in celebrating the birthday of one of the most brilliant female mathematicians to ever walk on this planet, Emmy Noether. Her name looks like it should be pronounced Noether, Noether, but it's actually pronounced Noether. She was born Amalie Emmy Noether in 1882 to Ida Kaufmann and mathematician Max Noether in Erlangen, Germany. She had 3 other siblings who were all younger. This included Alfred, Fritz, and Gustav. She grew up around the turn of the century, and her country was on the verge of World War I. And so, growing up during this time, especially in Germany, was very challenging. Noether is the acclaimed mathematician of a theorem called Noether's theorem. I'm not sure really which is more astounding, her theorem or the life that she lived in order to achieve the successes that she did. Technically, Noether's theorem isn't really a theorem or a theory. It's more of a mathematical proof that is used in physics to develop theories. Noether's theorem, in short, states that there are conservation laws of nature that correlate with symmetry laws in nature. In other words, in physics, there are laws of conservation that say that in an isolated physical system, the property measurements of that system do not change as the system evolves over time. That's conservation. Conservation remains constant, so it's conserved over time. It doesn't change. However, you only obtain that conservation if the system has symmetries. If the system does not have symmetries, then conservation laws do not apply. In other words, as long as the system has symmetries, you get conservation. So let's say you take a coin and you push it across the cement. The coin is going to slide along until it stops because the cement has friction. In this case, the momentum of the coin is not conserved. It loses momentum. So according to Noether's theorem, the coin does not have translational symmetry. Here's another good example. Okay, the moon rotating around the Earth. As it rotates around the Earth, it has angular momentum, and that momentum stays the same no matter what its position is around the Earth. In that instance, the angular momentum is conserved. As a result, the moon has rotational symmetry. If there's symmetry, there's conservation. If there's conservation, there's symmetry. That's Noether's theorem in a nutshell. Emmy Noether came up with a mathematical way to show the correlation between symmetry and conservation. It was brilliant. For visuals, I'm going to post a couple of videos on my website at mathsciencehistory.com that will help to further explain the brilliance behind Emmy Noether's theorem. Noether was a brilliant woman. Unfortunately, she endured obstacles to obtain the success that she did. She received an outstanding education that included piano lessons and extensive studies in French and English. By the time she was done with high school, she passed the examinations of the state of Bavaria for teachers, where women who graduated would go on to teach at girls' schools. However, she didn't want to be a language teacher. She wanted to study mathematics like her father did. However, this was a time in Germany when women were not allowed to go to college. Well, okay, they were allowed to go, but they were only allowed to audit the classes and not be students. So again, this was 1900 in Germany. So when she graduated high school, she left Erlangen to go to Göttingen in order to audit winter classes taught by mathematicians such as Otto Blumenthal, David Hilbert, Hermann Minkowski, and Felix Klein. However, after one semester, Erlangen opened up their universities to women. As a result, she moved back to Erlangen and enrolled in the mathematics program. She was the only woman enrolled among 46 male colleagues. She attended her father's lectures as well as lectures by Paul Gordon, and in 1907 she received her PhD in mathematics, graduating summa cum laude. For 8 years, she lived at home while she worked at the Mathematical Institute, substituting for her father. You see, her father had been handicapped since the age of 14 when he came down with a case of polio. His health at times made his work difficult. This allowed his daughter to substitute for him for his classes. In 1909, she joined the German Mathematical Association and gave her first public talk. In 1915, 2 professors, David Hilbert and Felix Klein, invited her to work at Göttingen University. However, she was not allowed to lecture because the philologists and historians did not want female professors. So, for 4 years at Göttingen University, from 1915 to 1919, David Hilbert let Noether lecture under his name. Finally, by 1919, women were legally allowed to teach, and Noether was granted an appointment to teach. However, she still received no salary. And so the math department at Göttingen University changed her title to associate professor with tenure. This allowed her to be paid through her supplemental lectures in algebra. She stayed at Göttingen University for 18 years, yet she was never offered a chair in the mathematics department because she was a woman. In 1921, she published one of her most important papers titled Theory of Ideals in Rings. It became the foundation of general commutative ring theory, and I'm actually a big fan of it. And I did an Instagram post on ring theory that I'll post on my website as well. Just look for me with all the curly hair. Okay, back to Noether. Her work was extraordinary. For almost 30 years, she contributed a wealth of knowledge to the development of mathematics and physics. Her work has been broken down into epochs of contribution. Her first was primarily algebraic invariance. The second epoch of her career contributed to ring theory, and the third epoch contributed to non-commutative algebra, linear transformations, and the study of commutative number fields. In other words, her contributions to physics and math were most outstanding. In 1928, she was invited to address the International Mathematical Congress at Bologna. In 1932, she turned 50 years old, and finally, accolades came her way. She was awarded the Alfred Ackermann Tübner Memorial Prize for the advancement of the mathematical sciences, and she was invited to give a plenary lecture at the International Mathematical Congress in Zurich. She was the only woman invited to give this lecture. However, things changed in 1933 when the Nazi regime took over. She was dismissed from Göttingen University. It wasn't just because she was a woman. It was also because she was Jewish. She was a member of the Social Democratic Party in Germany, and she was a pacifist. Her colleagues and peers throughout Germany made many attempts to reverse this decision. However, they were unsuccessful. Relentless in her pursuits to teach math, she continued to teach out of her home. Ultimately, though, like her contemporary Albert Einstein, she left Germany for the United States. In August of 1933, she took the position of guest professorship at Bryn Mawr College. In 1934, she began to give weekly lectures at the Institute for the Advanced Study in Princeton. However, she didn't like it there. She is actually quoted as saying that it is a men's university where nothing female is admitted. Noether taught for 2 years. Then, in 1935, doctors found a tumor in her pelvis. During surgery to remove the tumor, doctors found a cyst the size of a cantaloupe and 2 smaller tumors in her uterus. They removed the cyst and the additional tumors, and the surgery was successful. However, her recovery was not. 4 days after her surgery, Emmy Noether passed away from complications due to a possible infection. Shortly after her passing, a memorial service was held at the house of the college president. There, many great physicists spoke about her and her brilliance. Among them were Hermann Weyl, Richard Brouwer, John Wheeler, and Olga Todd. Around the world, tributes were written about her from Albert Einstein, Pavel Alexandrov, and many others. In her lifetime, among her colleagues, she was horribly missed and deeply treasured. She was cremated and her ashes were buried under the walkway that surrounds the cloisters of the M. Carey Thomas Library at Bryn Mawr. Noether faced many setbacks in her effort to pursue her true love, mathematics, primarily because she was a woman. She was a pacifist, she was Jewish, and she lived in a country that, at that time, was struggling under the oppression of an ugly, heartless regime. Nevertheless, she committed her life to mathematics and changed the landscape of algebra and physics. Some say that her contributions to math and physics rescued Albert Einstein's work on relativity. Einstein even referred to her as a significant creative mathematical genius. Her tremendous mark on mathematics and physics wasn't just mathematical, it was gender-specific. She was one woman who overcame so much gender bias and in the process inspired so many women to pursue mathematics, physics, and science. Her story even inspires me. Her endeavors weren't easy. Even more so, her mathematics weren't either. But she kept applying herself, looking for relationships in functions and operations, opening up doors to new forms of algebra, applying mathematical concepts in number theories that created conceptual relationships in physics. And she did this all while overcoming gender bias and running from a vile anti-Semitic regime. The pathway at Bryn Mawr serves as a perfect metaphorical reminder. No doubt, she overcame difficult obstacles, and in the process, Emmy Noether forged a far-reaching path for women in mathematics. As women in science, we often think about our hurdles, and we often feel like we are alone. But Emmy Noether's life serves as a perfect reminder for us women in STEM that our hurdles will always be there. And what really matters is that we refuse to let our circumstances dictate the outcome of our lives, that we refuse to be distracted from our cerebral ideas, and that we refuse to let our circumstances pull us away from our scientific ideals that allow us to contribute to science.